Good morning, friends. Today in this class, we will discuss on some common interview questions. Let's start with underfitting and overfitting. Let's start with the definition of underfitting. Underfitting generally happens when the model is not able to understand the relationship that exists between the features and that of the target. Okay. If the model is not able to fit your data well, then underfitting happens. Okay. The performance of the data is very poor, both in your training and in your test data. Okay, this is what is referred to as underfitting. Okay, the performance is very bad. This is something which you do not want, right? We need a model where the performance is really good, right? So if you look at underfitting, what happens is the model performance is very bad in the training data set and also in the test data set. Okay, this is what we call it as underfitting. Underfitting generally happens because of many reasons. It could be one of the reasons could be low data points that we have. The second reason could be there could be a bias in the data set, or the data may not be representative of the population. Okay, and it could also be a scenario where the model is very simple. Okay, or it could also be a scenario where we have used a wrong model for predicting or for doing some kind of classification. Correct. Right. These are all some of the reasons why underfitting generally happens. Okay, now there are different methods by which you can address underfitting. We'll look into that also. But right now, let's concentrate on the definition. Now let's look into overfitting. Overfitting is totally the opposite of underfitting, wherein the model is able to perform great in your trained data set. The performance of the model is very good in your trained data set, but what happens is in your test data set, the performance of the model will drop. Okay, this is something which is not acceptable because we need a model where the model is able to perform good on the test data also, right? And here the model is able to understand the relationship to a great extent on the trained data set, right? But when the data is new, or when the data is fresh, or when the model has not been exposed to a data on which it has been trained, the performance drops. Okay. Now the reason why this is happening is it's because of the complexity of the model. The model is so complex, or it is complex to such an extent that it is able to understand the relationship on the training data set, but when it gets exposed to the new data set, it is not able to do well. Okay, so example would be like the intuition is like this. Okay, you would have seen this given as an example in most of the classes. Okay, let's say that a guy is appearing for an exam and he is memorizing all the questions and answers, right? When he goes to the final exam, okay, like if he gets the same question, then he will do good. But if there is slight tweak, if he gets a different set of data or different set of questions, the performance will not be great. Right? The same thing happens over here, wherein the model is able to understand the relationship that exists between each and every feature with that of your target variable on the training data set. Okay, and when you expose it to a new data set, what happens is the model is not able to do well. It fails miserably. Okay, that is what you refer to as overfitting. Okay, but these overfitting and underfitting, right? These two things we do not want to have. We need an optimal state, which is neither underfitting or overfitting. Okay, we need to look at a model which is able to perform well, both on your training and also in the test data set. Okay, we need a model which is not having too much of accuracy. I'm okay to have errors, right? I'm okay to have misses happening. Okay, but it should perform well, right? It should be a generalized model. That is what is the requirement. That's the main intention or the goal that we have. Okay, now if you look at the graph, we have looked into overfitting, okay, underfitting, and also looked at optimum, right? If you look at overfitting, the pink dots that you see over there are the actual values, and if you look at the line, this line is your target, right, which is being predicted, right? If you look here, the model is able to understand the relationship, and it is passing through each and every data points over here. If you look here, look how complex it is, right? But when a new data set comes in, right, this square that you see over here is a new data set comes in, it is not able to predict, right? You see that the green line talks about the error that exists between what is being predicted and what is the actual, right? So basically the model performs good on your training data set, but it performs really bad on your test data set, right? This is what you call it as overfitting. Now let's look at underfitting. Okay, now if you look at underfitting, what is happening here is Again, over here, the pink dots represents the actual, right, and the line represents what has been predicted by the model. And you see a lot of gap between your actual and that of your predicted, right? This is the gap, right, which means that this talks about the error that exists, right? And this is happening on the trained data set. Now let's look into a new data which comes into picture, which is going to be a test data set. This is your test data set that you have here, the square mark, right? Over there, the error is increased, right? So basically what is happening is the model is performs really bad both on your training and on your test data set. Okay, the performance is very bad. Okay, now we don't want to have overfitting happening, we don't want to have underfitting happening, but what we need is optimal, right? Which is the ideal state. It is a generalized model that we are trying to develop, right? If you look here again, the pink line talks about your actuals, right? Which is used for your training, right? And the pink line, okay, and the pink dot, okay, and the blue line, right, represents what has been predicted by the model. Over here you see that there exists an error, okay. And if you look over here, the test data, right, which is the box, right, and the red box that we have here, over here also we see that it is very close what has been predicted, but there also exists an error, okay. This is the optimum state, right, wherein I'm okay to have error both on my training and also on the target, but it should be reasonable and it should be generalized prediction that I want, right? So this is what you call it as an optimal state. Okay, this is what is being required, right, when you build a model, right? So again, we don't want overfitting to happen. We don't want underfitting to happen. We want something which is in between overfitting and underfitting, which is nothing but an optimum state. I'm okay to have a model wherein it is not having very high accuracy, but the model performance should be good. It should be good both on the training and on the test data set. Okay, that is what is referred as generalized state or optimal state. Okay, so this is what I wanted to explain in terms of overfitting, underfitting, and what is optimum state. Uh, Going forward, we will start discussing on different interview questions. I will generate a different playlist altogether wherein you can see different interview questions, and we will try and explain in very simple way. Thank you guys. Take care.